Hey everyone, and welcome. Today, we're going to pull back the curtain on artificial intelligence and get into its single most important ingredient. It's the stuff that happens way before any of the flashy AI models start their magic, but honestly, without it, nothing works. So let's head into the kitchen and see how the real recipe comes together.
So let me just ask you this. What do you think is the real secret ingredient for building a truly great AI? Now, if you're thinking it's all about super complex algorithms or lines and lines of brilliant code, you're getting warm, but that's not the whole story. The real foundation, the thing it all rests on, is something much more fundamental.
Yep, you guessed it. It's the data. Amazing AI is built on amazing data. Simple as that. But here's the catch. Raw data is almost never ready to go. It's kind of like a messy pile of uncooked, unprepared ingredients. So to really make sense of it all, we're going to use an analogy I think you'll love. We're going to become data chefs.
All right, so any good chef knows that the very first job is to inspect your ingredients. In the world of data, this means understanding the shape of our data. We've got to know what we're working with before we can even think about what recipe we're going to make.
This is something we call data distribution. And don't let the fancy name fool you, it's actually a really simple idea. It's just a way of looking at how all the values in your dataset are spread out. Are they all clumped together? Are they spread out nice and even? Or are there some really weird, unexpected things in the mix?
Now, in a perfect world, our data would look just like this. A beautiful, normal distribution, what a lot of people call a bell curve. Just think of this like a chef getting a delivery of perfectly ripe, perfectly uniform tomatoes. They're predictable, they're easy to work with, because most of them are right around the average size. A ton of AI recipes are actually designed for exactly this kind of ingredient.
But then, what happens when you get something like this? This is a skewed distribution. I want you to imagine you ordered a big bag of grapes, but when it shows up, it's got a bunch of small grapes and one giant watermelon just sitting in there. That watermelon is what we call an outlier, and it is going to completely throw off the balance of your fruit salad, right? Well, that's exactly what skewed data does to an AI model.
And then there's this guy, a uniform distribution. This one's pretty easy to picture. It's just like rolling a fair die. Every single side from 1 to 6 has an equal chance of landing face up. In our kitchen, that'd be like having the exact same number of carrots, onions, and celery. You don't see it as often in the real world, but it's super important to recognize it when you do.
So here's the bottom line. The thing you really need to remember. Normal, bell-shaped data is predictable. It's easy for AI models to digest. But skewed data, with those outliers like our watermelon, can seriously mislead your AI. It can cause it to make totally wacky predictions because it's paying attention to the extreme cases instead of what's typical.
Okay, so once we've inspected all our ingredients and we understand their shape, it's time for the prep work. We can't just toss everything into the pot as is. We have to get it ready for our AI recipe.
This stage is called data transformation. And honestly, this is just the chopping, the dicing, and the seasoning phase of our cooking process. We're actually changing the data, its scale, its format, to make it way more consistent and easier for the AI model to learn from. It's all about getting our ingredients into that perfect state for cooking.
One of the most common prep techniques is something called normalization. Just look at this table here. On the left, you see age and income are on completely different scales. An AI model might look at that and think the huge income numbers are way more important, just because the numbers themselves are bigger. Normalization is like dicing all your veggies to a uniform size. We rescale everything, usually to a range between 0 and 1, so every single ingredient is treated with equal importance.
Okay, but what about ingredients that aren't even numbers, like, say, colors? An AI can't understand words like red or blue, so we have to do something called encoding them. It's actually a really simple process. We just swap out the text labels for unique numbers. Red becomes 1, blue becomes 2, green becomes 3, and boom! Just like that, our data is now in a language the AI can understand. It's a fundamental step.
So we've inspected our ingredients, we've prepped them, but how does this all fit together in the full AI cooking process? Let's take a look at the entire workflow, all the way from the raw ingredients in the kitchen to the final dish on the table.
So here it is, the whole journey from start to finish. First, you explore your data. That's checking its distribution. Then, you pre-process it, doing those transformations like normalization. It's only after that prep work that you finally get to the modeling, which is the actual cooking. And last, you interpret the results. That's like tasting the dish to see if your recipe was a success.
So why do we go through all this trouble?
All this meticulous prep work, well, it's because it has a massive, massive impact on the quality and the reliability of the final dish, your AI model.
All right, let's just recap the big ideas here. Distribution tells you the original shape of your ingredients. Transformation is how you reshape them for your specific recipe. And taking the time to do this prep work, it doesn't just make your AI more accurate. It makes it more reliable, more consistent, and even more fair. This isn't just a nice-to-have step. It is the absolute foundation of building effective AI, period.
And that brings us to a final and I think really crucial question. If an AI is only as good as the ingredients we feed it, if it learns from the data we give it, what hidden biases are we accidentally cooking into our systems? How we choose our ingredients and how we prepare them will literally be the difference between creating something amazing and making a complete mess.